Welcome to A Scientist Walks Into a Bar. Usually these episodes are recordings of our live Science on Tap events that we hold in Portland, Oregon and Vancouver, Washington. But today we're doing something a little different. Today we're talking to Kevin Peter Hand, who is a scientist and also the author of Alien Oceans, The Search for Life in the Depths of Space. Kevin is a scientist at NASA's Jet Propulsion Laboratory, where he has served as Deputy Chief Scientist for Solar System Exploration and is leading an effort to land a spacecraft on the surface of Europa. Kevin was supposed to do a live event here in Vancouver at the lovely Kagan's Theatre on April 15, and then, things changed, so we're doing something a little different. Today's episode is a little brief teaser where he talks a little bit about the book to give some idea what it's about, and then we're going to encourage you to go buy the book and give it a read. Then on May 28th, Kevin will be joining us for a live Science on Tap online event at 7 p.m. Pacific, where he'll be talking about the book and you can ask questions by chat. We'll put information in the episode notes about how to find that event, or you can look at our social media at Science on Tap ORWA. There's several ways that you can get the book, and I'd like to recommend two options for you. First off, the independent bookseller Vintage Books in Vancouver, Washington was supposed to sell books at our event, and clearly that's not happening. They are, however, taking orders online, so please check them out at vintage-books.net. Also, the publisher, Princeton Press, has given us a discount code if you purchase the book directly through their website. And I'll put all of that information in the episode notes for both Vintage Books and how to get the discounted book through the publisher. Also, one small note, Kevin wanted me to make sure to add that the thoughts that he expresses here are his alone and don't reflect views of JPL or the federal government. So with that, let's get started. Welcome to Kevin Peter Hand, who is joining us today from his home in Southern California, correct?
Correct. Eagle Rock, which is part of Los Angeles. And we're under quarantine down here and doing what we can to be safe.
Well, I'm so glad that you are able to join us remotely today. We had hoped that you would be able to come up here for the event on April 15th, but this will be the next best thing. So tell us a little bit about yourself and what do you do at JPL and what's your role there?
I'm a planetary scientist and astrobiologist, which means that I study planets and I study our home planet and I look for potentially habitable environments beyond Earth. And I use life on Earth as a guide to assessing whether or not some of these worlds beyond Earth could be habitable. And along with running my own lab, I am helping to advance several missions that could go out and search for life beyond Earth.
In the book description or your little bio in the book, it says that you are leading a mission to Europa. Is that correct?
Well, helping to lead a mission to land on the surface of Europa. I'm a team member on a mission called Europa Clipper that will fly by Europa. And I'm a team member on a mission that will get out to Saturn's moon, Titan, sending a rotorcraft to hop around the surface of Titan looking for signs of life. But yes, we're working hard in an effort to hopefully someday get permission to send a lander to the surface of Europa.
What is special about Europa?
Well, Europa is one of these worlds in the outer solar system that we now refer to as ocean worlds or moons of the outer solar system that are covered in ice and harbor alien oceans beneath their icy shells. And Europa is perhaps one of the premier alien oceans, and it presents a tremendous opportunity to search for life beyond Earth. It's got this 60-mile or roughly 100-kilometer deep global liquid water ocean, salty liquid water ocean, beneath its ice shell. And we think that the seafloor of Europa could have hydrothermal vents and water rock chemistry that could help build and power life within the ocean of Europa.
So what is special about oceans when it comes to potential planetary life?
Yeah, well, so that's sort of the biggest part of this question is that if we've learned anything from life on Earth, it's that where you find the liquid water, you generally find life. And so these alien oceans beyond Earth, these are places where the liquid water is today. And so we can go out and explore these distant oceans with the prospect of potentially finding life beyond Earth.
So are you looking specifically at planets within our own solar system or outside of the solar system?
Well, so these ocean worlds, these are moons of Jupiter, moons of Saturn, moons of Uranus and Neptune, and Pluto possibly even falls into this category. So these are all worlds within our solar system. But they could also be the type of moons or planets that exist around other stars. And so as we continue to explore our own solar system, we certainly have an eye towards these exoplanets and the type of potentially habitable environments that might exist elsewhere in our galaxy.
I'd imagine it's a little bit easier to get to moons of Jupiter than some of the exoplanets. So
That's right. Yeah, and that's there's so much to explore, and I would love to get to an exoplanet, but for now we're limited to using telescopes to receive light and signals from exoplanets in order to figure out what's going on there. Whereas these alien oceans, these are places to which we can send robotic spacecraft, and those spacecraft could search directly for signs of life.
So what is the benefit if we find signs of life on another planet? Why are you trying to do that?
Well, think about it this way. Roughly 400 years ago, Galileo turned his telescope to the night sky and looked up at Jupiter, and he was able to see these 4 little points of light around Jupiter. And initially he thought that those were just stars that he could not see with the naked eye. And so he called them the stars of Medici. And that was because the Medici family was funding his research, and Galileo was no idiot. But night after night, he charted those little points of light, and he discovered that they were not stars, but rather moons of Jupiter. And that was heretical. Back then, nothing was allowed to revolve around anything other than the planet Earth. And so Galileo got into a lot of trouble with the Spanish Inquisition. But in the end, Galileo's careful observations helped put the nail in the coffin of Aristotelian cosmology. The idea, of course, that the Earth was at the center of the universe and everything revolved around the Earth. And he opened the doorway to the Copernican Revolution. The idea, of course, that the sun is a star and the Earth goes around the sun and all the planets go around the sun. And the stars that we see in the night sky could well be suns to their own planets. And so with that advancement, Galileo revolutionized our understanding of physics and our place in the universe from a physics basis. And in the decades and centuries that would follow, new tools and technologies would help us understand that the principles of chemistry work beyond Earth. And that would spark a revolution in chemistry. And then with geology, we would come to appreciate that geology works beyond Earth. But when it comes to this curious little phenomenon that we know and love and call life, when it comes to the science of biology, that fourth fundamental science, we have yet to make that leap. We don't yet know whether or not biology works beyond Earth. And that's part of what excites me about these alien oceans. We have the potential to make this great discovery and answer this age-old primordial question of whether or not we are alone.
That sounds fascinating. Thank you for that.
Well, thanks. I love it too. So
I'm a bit of a Galileo fangirl myself, so I appreciate that.
Excellent.
The book starts with you at the literal bottom of the ocean with director James Cameron, actually. How did that happen? Why did you start the book out there?
To sort of draw the reader in and to give the reader an experience of what these environments are like. And That, as I mentioned in the intro to the book, I grew up in a small town in Vermont, nestled in the Green Mountains, and so being out at sea and then on top of that going down in a submersible was a bit of an alien experience for myself, and so I thought it was a nice way to start the book.
Yeah, it sounds a little terrifying, but fascinating at the same time. So, and how many trips did you make? It was many, right?
Yeah, I had the great fortune to go down in a submersible 9 times and spent the better part of 3 months at sea over the course of that year, and since then I've spent many more months at sea and up in the Arctic and down in the Antarctic, and I've been quite fortunate in my journeys around the home planet and getting to see life in all sorts of extreme environments.
So specifically on those dives to the bottom of the ocean, what did you learn during those dives that is helping you with your exploration of space?
Yeah, well, so the big picture here is that when you look around you on the surface of planet Earth and you look at all the life that surrounds us and on which we depend, you can follow the food chain down to the bottom, and as we all appreciate, the food chain, the base of the food chain on the surface of the Earth focuses in on plants and photosynthesis. Well, in the deep, dark depths of our ocean, sunlight doesn't reach any life down there, and yet we find incredibly abundant ecosystems around these hot springs, these hydrothermal vents that are on the seafloor. And these hydrothermal vents, these very chemically rich systems, give rise to chemosynthetic microbial communities that then serve as the base of the food chain and help feed the higher levels of the ecosystem. And so chemosynthesis, not photosynthesis, is what's powering those ecosystems in our own ocean. And we think that in these deep, dark, ice-covered oceans beyond Earth, similar metabolism, similar ways of getting the business of life done using chemosynthesis might also be viable. And so there's a lot of lessons learned in terms of looking at the chemistry and geology and biology of those systems that helps us better understand what could exist out there and also how to look for it.
I don't want to give too much away in the book, but you talk about some of these planets and the different environments that they have, like was it Titan that had the ice 3 at the bottom of the ocean, or different kinds of things. How do we figure that out, and how would life live in something like that?
Yeah, some of these larger moons of the outer solar system, like Titan and Ganymede and Callisto, these moons are interesting in that they're so massive and large that instead of having rocks at the base of their seafloors, they likely have other phases of ice. And this isn't something that we experience here on Earth. Ice on Earth is ice 1 and it floats. But if you get up to high enough pressures, the water molecules in ice will rearrange themselves into another form of ice where the water molecules are packed a little closer, making the ice denser. And that kind of ice, like you're saying, ice 3, and there are a bunch of other types of ice, it becomes so dense that it sinks. And so on these larger moons of the outer solar system, we might actually have ice on the top of the ocean and ice as part of the seafloor. And that's really cool, but it also could be limiting for some of the water-rock interactions that we think life as we know it might depend on. You wouldn't have, for example, hydrothermal vents if you had an icy seafloor.
Right. Yeah, that would be difficult. Interesting. And I imagine that if and when we find life on other planets, that will give us a new lens to figure out, I realize that extremophiles and Yellowstone and those kinds of places where people thought, oh, nothing can possibly live there. And now we have a whole new view of where life can be. That's going to be a fascinating revolution.
That's right. And it also one of the key aspects of all this is searching for a second independent origin of life, an origin of life that is not connected to our own tree of life here on Earth. And these far and distant oceans could be great places for a separate origin of life. And we can go and we can look for extant or living life within those oceans today and see whether or not it runs on a similar biochemistry to ours, see whether or not it uses some different kind of large biomolecules. All life on Earth, for all of the diversity of life on Earth, from the largest of blue whales to the tiniest of microbes, everything runs on DNA, RNA, and proteins, and ATP for that matter. Is that commonplace? Is that kind of a convergent biochemistry, or is there a different game in town? Is there a different way to get the business of life done? And these alien oceans are great places to potentially answer that question.
Well, great. With that, I think we will say thank you for this short preview episode, and we look forward to having you talk about it in a lot more detail when we have you at one of our Science on Tap online events in May.
Excellent. Thank you so much, Amanda, and thanks so much to all your listeners, and look forward to talking with you more.
Thanks for listening. As I mentioned, Kevin is coming back on May 28th to do one of our Science on Tap online events at 7 p.m. Pacific, and I'll put information in the episode notes on how to find that event. We hope you can join us. Also, we plan to keep our podcast and Science on Tap online events free and accessible to everybody, but we can't sell tickets to our live events anymore, so we don't have any income. I know that there are a lot of people struggling out there, and I don't want to take anything away from anyone. But if you value what we do and you can spare any extra, we would greatly appreciate you supporting us through Patreon. We are working with our nonprofit partner, an organization called Make You Think, and you can find the fundraiser at patreon.com/makeyoutthink. And of course, I will put that in the episode notes as well. I have a couple quick thank yous. First, thanks to Princeton Press and Sarah Henning Stout for helping put this together and getting the discount code. Next, to Graham Tully for sound production. And finally, to Jonathan Coulton for letting us use his song Mandelbrot Set for our intro music.
One badass fucking fractal, and you're just in time.